Skylten utanför Park Hotel i Göteborg snurrade fortare och fortare i vinden. Vindkraft om ni så vill, också en möjlighet att göra elektricitet. Och inne på hotellet i dagarna 3 diskuterade man många andra möjligheter att göra elektricitet och använda den rationellt. 400 experter, forskare från 20 länder. Framförallt diskuterade man hur man skulle kunna spara elektricitet. För som Vattenfalls generaldirektör anmärkte i sitt inledningsanförande, vi lever över våra tillgångar.
The UN Commission on Environment and Development also makes it clear in its report, Our Common Future, that we are consuming too much of our natural resources today. We have to review our lifestyle and what our economic growth actually entails. The term growth must be given a new and wider meaning. The Brundtland Commission talks about creating a sustainable development, a sustainable world.
Man hade ett stort forskningsmaterial och man ville gå på djupet. Många experter hade i förväg skrivit uppsatser som tryckts i en tjock bok som skickas ut till deltagarna. Därför satt man här i smågrupper och diskuterade vidare vad alla redan hade läst. Forskningens senaste rön, alla tänkbara aspekter av energibesparing. Man gick på mottagningar och man gjorde utflykter på kvällarna i Göteborgs vackra skärgård. Vi ska försöka sammanfatta 3 dagars diskussioner och det här kan vara en plats så god som någon att börja ute i naturen. Det är nämligen ingen konst att göra elektricitet med kol eller gas eller olja. Det är bara det att kol eller oljebrasan släpper ut så mycket som håller på att förstöra vår jord. Koldioxid till exempel samlas i atmosfären. Det blir som ett växthus. Temperaturen stiger på jorden, vattnet här i havet stiger, våldsamma stormar drar fram. Kan vi överleva, vi människor?
We probably will have an increased temperature. This may speed up the carbon dioxide cycle in the biosphere. You have a lot, for example, of carbon accumulated in the soil, especially in Scandinavia and countries like this. If you now have an increased temperature, probably this will start a decomposition of this organic material and in this way contribute to an explosion.
If there is something in it, and you do have really what will be quite, or could be quite a rapid change in climate, then you have whole population infrastructures that are set up to handle a particular situation, which find themselves either living in circumstances where they were once a heavily agriculturally biased country. They cannot produce the food, they wouldn't be able to buy it. Other countries like the United States may find that they really would have to take over Canada because Canada was growing all of their wheat for them. So I think that the actual political implications, if it's true, that there is going to be this kind of risk from CO2, are actually very, very serious and are very destabilizing.
I'm convinced that this issue will be the dominant factor in making fuel choice well within the planning cycle of utilities. As it's not happening today, but I think that very soon this is going to be the dominant issue in fuel choice. And coal, which is the most noxious of the fuels from a global warming standpoint, does not look very attractive under any circumstances.
It's not going to be very easy to resolve that question as to what to do with coal. And I think that what has to be done with coal question is to devise a strategy that builds a lot of flexibility into our planning. And in any case, I think that the gas turbine approach to the coal problem is a very interesting one because it gives you a lot of flexibility.
We can decide today to stop every coal burning or every fossil burning plant in the world tomorrow. And essentially, we're still going to have to do a lot more to have any impact. And we really have to bear that in mind, the fact that coal is a reality and is going to be for some time yet. And so we've got to take other actions, which will be the industrialized world will have to bear the burden of the developing world's CO2 emissions.
Men det finns andra sätt att elda kol. Förgasade, då kan man rena gasen först. Effekten stiger dessutom, utsläppen av koldioxid sjunker. Forskare från Tyskland berättar om sina försök på konferensen. Och ska man nu utgå från gas, då ska man bränna det i en gasturbin. Och forskare från Amerika berättade om de nya motorer som utvecklats härifrån, ifrån jetplanen. För mycket pengar och mycket forskning har lagts ner på att göra effektivare jetmotorer. På köpet har man fått motorkonstruktioner som går att använda också för elproduktion. Det är en teknik som är lämpad också för utvecklingsländer. Nästan alla har ett flygbolag och kan därför serva jetmotorer. Ska man sedan göra det miljövänligt, då ska man odla energiskog, snabbväxande träd. Och av biomassan ska man göra gas, och när man bränner den tas koldioxiden upp av nya träd som växer upp. Efter de forskningsrapporter om förgasning av biomassor som presenterades på konferensen kan man fråga, är det här redan en utarbetad teknik? Kan vi göra det imorgon?
I was asked in the morning session this morning how long until this technology is available, and I said 5 years or so. And I was corrected by the gentleman from Studsvik who's been working in this area for quite some time, and he said it's more like 7 years. But the point is that the time scale is very short for development of this biomass gas turbine technology.
That you don't know how to solve yet?
Basically, the components of such a system are well understood. It's a matter of putting them together and running it and figuring out what happens when you put them together and the bugs that need to get worked out. But it's not any fundamentally new technology that has to be developed at this point.
How much in Sweden, how much biomass do we have? Could we shut down the nuclear reactors and run biomass? Is that at all a possibility?
We've made estimates of how much electricity you could produce using biomass that is currently not used for any other purpose, not for pulp and paper or any other industry, and that includes residues in the forests as well as using surplus agricultural land for plantation fuel wood. And if you take that potential and use it in very efficient gas turbine systems, you could produce up to 3/4 of the current electricity that's produced using nuclear plants.
There is a question mark concerning the potential of this fuel, no question about that. There is also a question mark concerning the impact on the environment, and I'm not talking about emissions from the fuel burning, but also on the forest and where you take the fuel, recycling of the ashes. No question about that biomass based electrical production is a very big potential, and certainly one has to have a deep look into it, but and we will do that, but we should not today hope that the biomass should solve our future energy problem. I think it will be a mixture. Concerning the gas turbine, I think it's true that gas turbine, whether it's Stieg, E-Stieg, combined cycles or any other concept, will play a very important role in the future Swedish electrical production system.
Framtiden, som inte är så avlägsen trots allt, berördes också i flera diskussionsmöten. Solceller till exempel.
The key to photovoltaics has been and will be reduction in cost, but there's a tremendous learning curve that we're on. The prices have fallen from $100 per peak watt in the 70s to $20 per peak watt in 1980 to about $4 per peak watt today. And what we're projecting with new thin film technologies in the early 90s will be producing at about $1 per peak watt. And at that time, it'll become of interest to utilities, certainly in the southwestern part of the U.S. And I think in the mid to later 90s, it'll start having impact in places like Sweden.
Och sen talade man om bränsleceller. Små grå lådor som redan tillverkas i Japan och om 2-3 år kommer i massupplaga. Bränslecellen går på naturgas och ger all värme och elektricitet man behöver till ett konkurrenskraftigt pris redan om några år.
The Japanese have already produced such a system in a miniaturized form with a size of 2 by 3 by 1.5. So they are almost to the size of the box of the fuel cell only, but now for the complete system, miniaturized with hydrogen processing, control systems, everything.
And what will it be in the future? You buy your little grey box, it's enough for this hotel, for example?
You will buy, for this hotel, you'll buy a grey box of maybe 6 by 2 by 2.5 meters, and it will be sufficient for all the electric power needs as well as the heat.
For the hotel. When will this be?
I would say a commercial availability within 3 to 4 years.
When will you be able to join up with Dr. Blumen over there and put your photovoltaics on top of the fuel cells and nothing will come out except electricity and heat?
Well, I do believe that, and several other speakers have said, that there is a direction where photovoltaics can couple into other technologies, fuel cells and a hydrogen economy, to produce a power generation system that will be basically pollution-free. However, there's a number of developments and infrastructure and so forth that has to be built up, and it will take quite a bit of time before that'll have significant impact. In the meantime, the photovoltaics industry is just trying to make money in niche markets, build ourselves up, be profitable, and be there when we're needed.
Year 2010 is a magical year in Sweden because they will close the nuclear reactors. Will you be ready?
I think it's possible by 2010.
Men det gäller alltså produktionen av elektricitet. Den andra och minst lika viktiga frågan är att använda elektriciteten rationellt, spara på den. Vare sig den görs av gasturbiner eller vattenkraft, kommer från olja, kol eller kanske till och med kärnkraft.
You have had a situation where electricity politics and oil and gas politics went their separate ways rather than being integrated with each other. And one of the meanings of this meeting is that the electricity politics is going to rejoin the oil and gas politics to create an energy politics in Sweden, something which really has been absent. So the bad news is that Sweden in effect lost its way for 10 years in energy policy, as best I can discover, by having a separate electricity politics from its oil and gas politics. The good news is that Sweden has superbly performed in its oil and gas politics. And so you have had among the best records of implementing, setting goals, setting standards responsive to those goals, running pilot projects, having evaluations of those projects which are both sensitive to technical factors and to behavioral factors, and then to implementing in a widespread way new technologies. Many of us have been in great admiration of what Sweden has achieved in the area of energy use in buildings, particularly on the thermal side. Virtually no country in the world has had the success you have of bringing new technologies and new concepts into the field. And so the good news is those success stories, those qualities of a culture, being able to set a goal and get something accomplished, are transferable. There's not any dramatic differences between the job of saving electricity and the job of saving oil and gas.
Det finns ingen brist på ny teknik som fyller samma uppgifter som äldre teknik men bara drar hälften så mycket ström eller mindre. Detta till exempel är en ny lampa som presenterades på konferensen. Där har man lyckats med att med ett tunt metallskikt stoppa mycket av värmeutstrålningen. Resultatet är att lampan ger samma ljus men till minst 50% mindre strömförbrukning.
The technology, which is quite significant, will also be used perhaps even for fluorescent and other types of light sources which are widely used throughout the world, and fluorescent of course becoming the most popular source in the world even for residential lighting. So this is some new technology that only 2 weeks ago came to the surface. It was not included in the chapter, and we thought it would be significant to present it to this conference.
How much will it cost?
That's the question that always comes up in the sessions.
Otherwise we won't buy it, you know.
Yes, we understand. The cost adder, and there is a small adder, is not particularly significant compared to present technology. Typically in a lamp that will be commercially introduced yet this year, we think the cost adder will only be about $2 per lamp out of a total cost presently of about $8 or $9 per lamp. So the cost is modest, the payback is very rapid within a month or so, very short compared to the lamp life. So it looks like a good economic result.
This is one example of what can be achieved. This refrigerator has been developed by this laboratory here in cooperation with the manufacturer and Ministry of Energy. It consumes about 85 kilowatt hours per year compared to the normal 300 to 400 kilowatt hours per year.
När det gäller alla de elektriska apparater som används i hemmen finns det väldigt mycket möjligheter till besparingar. Tekniska lösningar som redan är utarbetade eller snabbt skulle kunna utarbetas om det fanns något intresse för det eller om det krävdes.
From our analysis and our experiments also, we could rather easily over some years reduce our electricity consumption to half or even down to 1/4, a quarter of what we use today, and still maintaining the same material comfort and standard of living.
How much do you save by variable speed?
Well, with these, in the particular experiment that we did here, we observed for the supply fan an average savings of about 45% over the year.
2/3 av all ström i USA går till elektriska motorer. De går oftast med konstant hastighet, men skulle man kunna variera hastigheten efter vilken kraft som behövs för tillfället, då skulle man kunna spara oerhört mycket. Hur mycket?
One of the big issues in motor drives is that we really don't know what the potential is. And I think there's a real opportunity for a pilot program with industry to go out, measure actually how much is possible to save in industry. It's a chicken and egg problem. Nobody knows about the potential savings, so people are afraid to invest. It's a conservative industry. They don't want to take risks. Because they're not buying the motor drives, you can't get mass production underway. Without mass production, you can't get the price down. So it's a vicious cycle that is hard to break until there is somebody willing to take a chance.
Is there so that if you put it all over the line that we come up to about, well, should I guess, 10% of the electricity production of the United States should be possible to save by introducing these motors everywhere it was made any sense to use them?
The various estimates that I've heard and that came up by participants in our discussion yesterday range from 6% to 50%.
From 6 to 50?
From 6 to 50. And so that shows that nobody really knows what's going on.
But anyhow, we're talking about savings that is in the United States that is more than all of Sweden is using in electricity.
Yeah, easily.
Today we make steel and cast steel into heavy blocks. If you want to make a paper thin sheet, you start with such a dimension, 2-3 meter wide and 300 millimeter thick. And then you roll and heat and roll and heat and roll and heat and roll and heat for a long, long time. So why don't we produce the strip directly from the mill? It's quite possible, it will come. And so we can cut away the hot rolling at least.
How much would the savings be, percentage-wise?
That would save a lot of heat, and it would save, if we did this with conventional method, we would use 5,000 kilowatt hour per ton with this very thin material, starting from thick billet. So if we go directly to this, which is done with this thing, we save 5,000 kilowatt hour per ton. That's quite a bit.
Allt detta och många andra möjligheter att använda elektricitet rationellt och spara mycket diskuterades i smågrupper under dagarna 3. Inte i föreläsningar i första hand, utan en kort berättelse bara av den som skrivit den vetenskapliga uppsatsen i stycket och sen en öppen diskussion.
Individual factory owners are not continuously renovating their processes.
Here is a new end-use sector that has not received adequate attention. Let's begin doing some things.
And if you look for this diagram.
Allt var dock inte inriktat på att spara elektricitet. Här talar man till exempel om elektrotermisk uppvärmning, Allt från mikrovågsugnar i köket till industriprocesser. Och det kommer mer och mer och ökar användningen av elektricitet. Men ett effektivare sätt att värma och därför spar det energi totalt.
There's no emission and pollution on the user side, and that means the working conditions are much better as using for the same process fuel-fired systems.
Electricity, it's such an useful energy carrier that it will continue to have a unique position in modern societies.
När det gällde Sverige mynnade allt ut i en uppsats som hette Challenge of Choices, presenterad av Birgit Bodlund. Kan vi klara oss i Sverige utan elektriciteten från kärnkraften och vad kan det tänkas kosta? Man presenterade en lång rad olika scenarios byggda på hur mycket elbesparande ny teknik som kan komma i allmänt bruk. Om ingen effektivare teknik tas i bruk kommer vi att göra av med 190 terawattimmar år 2010. Om elpriset går upp med 50% uppskattar man att vi kommer att göra av med 140 terawattimmar år 2010. Men om vi använder effektivare teknik i olika tänkta scenarios så kan det bli något från 110 ner till kanske bara 88 terawattimmar år 2010.
Which scenario do you prefer? What do you think is realistic?
The first graph I showed you, it showed where I think we will end up, and that's where Vattenfall have the prognosis.
That is 146.
Well, it's the somewhere in the interval 120, 170. That's where I think we will end up if we don't do quite a lot of things.
But you also know what's happening in Sweden today, that some of the people that were against nuclear energy starts to ask themselves whether we can live without it, whether that will hurt our industry, whether we will lose the jobs. The unions, for example, say this thing. And then they find a paper addressing itself especially to this point, and they got lost somewhere in the middle there. So they go to the conclusion, and they don't find a clear answer to the question, can we live without nuclear energy and will we suffer, and what will it cost? Or can't we? Why isn't that spelled out in the conclusion? Yes, please.
We can live without nuclear. It's a question of how we produce the power that we need. And that we can do in some way, but we haven't said exactly in what way, because that has to be chosen by you.
Why didn't you? I mean, I go to the electricity reporter, there I can read it. It would be possible to phase out nuclear power production without having to build new hydropower stations and without increasing the emission of carbon dioxide. Finally, all these benefits would be achieved without increased costs and without reducing the amount of energy service provided by the power system. Yes. Is it right or is it wrong?
Well, we didn't write a newspaper article. We wrote another kind of a piece.
Would you sign it? Is it right? Is that? I mean,
yes, it's right.
It is right. We can.
What you just read to us is right.
May I ask you if you could write the first paragraph for example, the journalist I met down in the doorway down there. His question is exactly the same. Can we survive without nuclear power, and how much will it cost us? Just one paragraph.
Well, the answer is yes. And the cost, according to these scenarios, if we make the better one of them come true, is less than the electricity cost today per kilowatt hour equivalent.
It can't be right that the system we have today, which has one of the lowest electricity prices in the world, will be worse than this theoretical one they have talked about.
The price of electricity, will be higher than at present, but the bill to the consumer will be equal or lower. So this is, I think, the situation that we have described. And
so what you mean, Thomas, is that if you go to the efficient scenario, industry, for instance, will use less kilowatt hours than today, and the electricity price will be higher in the efficiency scenario than in the system of today, but they buy less kilowatt hours.
Exactly, and the cost they have to reduce the number of kilowatt hours they buy, electric they buy, are sufficiently low for this total outcome to be the place. The total bill is lowered, although the kilowatt hour price paid to the utility is higher.
Yes, and there we come to the time scale.
Yeah.
We haven't this equipment today.
Will all these things be implemented voluntarily, just by being there? Or do we have to do something in order to get them implemented?
Oh, I'm sure we have to do quite a lot.
Like?
Of course, we must inform our customers, the market, about the pricing, the signals on of the costs, and that is essential, but that is not enough.
And then? So what you need
then
to
we
do
have
more?
to learn ourselves more to be able to help our customers to be more aware of energy questions from different point of views.
But it all seems to be voluntarily. You'll inform them and then they suddenly go and put in smart windows, so they change their motors in the industry and they have heat pumps and all.
Well, I think from my point of view, our industry has to do very much in this respect, and we have not done very much in early times.
Persuasion is by sure a nice tool, but it's not so efficient. Christianism was imposed by persuasion, but it took 300 years. I don't think we can afford to wait for 300 years until energy conservation will be in the mentality of everybody. So I recommend that a little bit of a brute force method has to be pursued. So this must be translated in regulations, in laws, and in acts.
We do have regulations for what kinds of plugs you can use in wet rooms. That's for your health and safety. So you could imagine having certain rules for the environment's health and safety. And I think it's no more strange than having catalytic converters on cars to have certain demands on refrigerators. For instance, let's grasp the opportunity when we are having to change the entire refrigeration technology because we are having to get rid of the CFCs anyway. Why not also get low energy appliances at the same time?
Well, I think you wanted to, if you have these important societal goals, and you decide they're important enough, like any other law. I mean, you force people to observe certain speed limits or not to knock each other over the head. If you decide it's really important to do something about the environment, if you decide it's really important to get rid of nuclear energy because of its danger, then you have to take some measures to achieve that. And here the measures are vast that have to be achieved. So to do it, it's going to take at least setting certain minimum levels. And then the utility should get involved very heavily in creating incentives so that people will want to exceed those minimum standards. But the standards are very effective because the standards reach everything that's on the marketplace in a way that no price signal can possibly do. And you have these market imperfections that are enormous. The consumer won't do it on his own. You need to have rebates. You need to have promotional programs, the programs that have been really successful in the United States.
I don't like that we, as a utility, have to force people to choose a different, a special sort of freezer or washing machine. We would like to tell our customers that if you choose that one, it will cost you so much. If you choose that one, it will cost you the same amount of money, but you could also earn on the electricity bill.
Even though standards and demonstration projects and information are absolutely essential, these are somewhat complicated ways of doing things that can also be done through price. Sometimes I have the feeling that people take extremely circuitous routes in political situations to avoid doing something which is obvious but politically unpopular. And I think that although it's rather difficult to calculate exact elasticities, it's definitely true that when the price of electricity is high, or another way of putting it, when the price of electricity reflects the true cost,
including environmental costs, then people will find ways to use less.
Och så här fortsatte dagarna 3. En generalmönstring av allt som kan göras för att spara elektricitet och tillverka den rationellt grundvalen för en komplett energipolitik för vilket land som helst. För alla länder är nämligen i samma situation. Vi lever över våra tillgångar, vi förstör vår jord i hastig takt och vi måste, som Vattenfalls generaldirektör sa i början, radikalt ändra vårt sätt att leva och sluta slösa med tillgångarna. Och det finns fler möjligheter att spara energi än vad man först kan tänka sig. Men det är experterna, kraftbolagen som får hjälpa konsumenterna att hitta rätt bland alla de olika möjligheterna.
We don't know enough about individual preferences. We don't know enough about how to find out individual preferences. Marketing is the name of the game that lies ahead. Getting these energy technologies really into the field. They're all moving more slowly than they should, and it's because we haven't had the kind of help from the private sector represented, the state-managed private sector, represented by the kinds of people who are here in such numbers today. And it's a really thrilling opportunity for those of us frustrated by the rate of dissemination of energy efficiency technologies to have the kind of possibility of partnership that is represented by this meeting.
We can see a new vision emerging, not only in Sweden but also in other countries, where the traditional excellent utility, in other words, the one that provides high quality of service plus low cost, high quality and low cost of service, adds two more skills. And what is in the future will be an excellent utility is one that will provide high quality of service plus have the skills of coordinating a number of different smaller and larger suppliers outside the utility itself. Plus a utility that has the skill of promoting high energy efficient use. I think this broadening of the definition of what is an excellent utility is actually what we're seeing right now. Now, this takes time, obviously. But then again, if we look at Vattenfall of 1989, Vattenfall of 1989 is not the same thing as Vattenfall of 1985, and it's definitely not the same thing as Vattenfall of 1980. I don't think it would have been at all possible for Vattenfall to have a conference like this in 1980.